Usually when we talk about a medical diagnosis,
Right.
there's this expectation of absolute precision. Like you break your arm, the x-ray shows that jagged white line, and the doctor just points to it.
Yeah, it's very clear cut.
Exactly.
Yeah.
Broken or not broken. It's a binary reality. But the moment you step into the world of data analysis, that crisp x-ray machine is it's completely
Oh,
useless.
totally
You're
useless.
suddenly staring at millions of rows of sales figures or customer logs, and it is just raw diagnostic chaos.
It is murky by default. I mean, there's a running joke in our industry. As a veteran data architect with, over 10 years in the trenches with Alteryx and Tableau.
You've seen the chaos firsthand.
Oh, yeah. The joke is that data professionals spend 80% of their time cleaning data and the other 20% complaining about having to clean data.
That is so true.
Because the raw material is almost never ready for actual analysis.
Which brings us directly to our mission for you today. Welcome to today's deep dive into datok E04, Preparation Essentials. We are cracking open a massive stack of technical documentation and system guides for datok's prep module.
And as a technology analyst and educator, I'm super excited for this one.
Same here. Our goal is to explore how this system takes those messy, chaotic spreadsheets and actually turns them into pristine data sets. And we're doing this through the lens of a platform that operates entirely offline.
Which is huge. That offline architecture is a massive paradigm shift. I mean, in a landscape where everyone is obsessed with pushing data to cloud servers.
Right, the magical cloud.
Exactly. Datok deliberately pulls everything back down to the local machine. It creates this absolute guarantee of privacy and compliance simply because your data never actually leaves your hard drive.
Let's unpack that, because before we can start using the prep tools to transform data, we really have to understand the physical workshop we're operating in,
You do.
The documentation states that datok is a browser-native web application. There's no software installation or downloads required at all.
Which still blows my mind a little bit.
Right. It processes everything locally on the user's disk, specifically in a directory path on your C drive, under your user documents folder, and in memory within the browser.
Yeah, leveraging your browser's origin private file system, or OPFS, for what they call unlimited data scale.
But wait, in an era of quote-unquote unlimited cloud scale, local processing is bound by physical reality. I mean, we are essentially trying to fit an ocean into a backyard swimming pool here.
Well, you are dealing with strict physical boundaries. The application loads these active data sets and the visual node graphs directly into your browser tab's memory.
Okay.
And that introduces a very real, very rigid hardware limitation. Browser tabs enforce a maximum JavaScript heap memory size.
Right.
So depending on your specific browser and operating system, this limit usually caps out somewhere between 1.5 gigabytes and 4 gigabytes.
See, I have to challenge that limitation.
Go for it.
I am sitting here right now with a laptop that has 32 gigabytes of RAM. Why is my browser artificially capping my data pipeline at 1.5 gigs? That just seems incredibly restrictive for modern data engineering.
It definitely feels restrictive. Until you look at how web browsers are actually engineered.
Right, lay it on there.
So browsers use specific JavaScript engines like V8 for Chrome or other Chromium-based browsers.
Right.
These engines were originally designed to run lightweight scripts on web pages. They were not built to process 10 million rows of enterprise financial data.
That makes sense.
Right. So to keep your system stable, the browser isolates every single tab into its own sandbox. It allocates a contiguous block of memory, that heap we talked about.
Yeah.
And if a single tab demands more than its allocation, the browser just kills the process.
Wow.
It does that to prevent your entire operating system from locking up.
So if I ingest a massive CSV file and try to pull tens of millions of rows into the datok canvas at once...
You're going to hit that wall instantly. The tab crashes and you get an out-of-memory error.
Ouch. Now, the documentation does note that the physical disk data remains uncorrupted when this happens.
Which is a huge relief.
Yeah, definitely. But the pipeline still halts. So how are we supposed to build heavy analytical pipelines if we're constantly tiptoeing around a 4 gigabyte trapdoor?
Well, by fundamentally changing how you construct the pipeline in the first place.
Okay.
Datok requires its users to be mindful architects, rather than just relying on brute force compute. The solution here is downsampling during the design phase.
Downsampling.
Exactly. You don't build a skyscraper by pouring all the concrete on day one, right? You build a scale model.
Right.
In datok, you use tools like sample size to intentionally restrict the data set.
So I tell the system to only bring in like the first 1,000 rows or maybe every 100th row just to give me a representative slice of the chaos.
Precisely that. You construct your entire logic, your filtering, your transformations, your mathematical models on that tiny, manageable footprint.
Because the JavaScript heap is perfectly happy handling a few thousand rows.
Exactly. It breezes through that. And once you verify that the pipeline logic is flawless, you trigger the full extraction.
Oh, I see.
At that point, datok streams the full dataset directly to the local SQL8 database on your disk. It bypasses the visual browser memory bottleneck entirely.
That makes a ton of sense. If our visual sandbox is that constrained, then the very first thing we have to do when data enters the pipeline is just throw all the unnecessary ballast overboard.
Yes. Shed the weight.
We need to move from managing the physical environment to dictating the macro structure of the data itself.
And the structural phase is almost always where you start. When you import external vendor files, whether that's an old Alteryx file, a Tableau extract, or just a massive raw text file,
Right.
they inevitably come with dozens of columns that have absolutely no relevance to your specific analysis.
Enter the Select Columns tool. I read through this section and immediately pictured this incredibly strict nightclub bouncer.
Oh, I love that analogy.
Right, because instead of just letting all the raw data flood into your precious RAM, this tool stands at the door with a clipboard. You use these visual checkboxes to drop unwanted attributes. The bouncer turns away anyone not on the list.
Exactly. You're not on the list, you don't get in.
But it goes beyond just dropping columns. You can also rename technical headers. So if a legacy database spits out a column named like custodfin000.
Oh, I've seen way too many of those.
Yeah, we all have. You can assign a custom alias right there, like customer financial ID, which makes downstream analysis significantly less miserable for the human actually reading it.
The human readability is a really nice benefit. But honestly, the most critical function of the Select Columns tool happens beneath the surface.
Oh, what's that?
Typecasting. You aren't just letting data through the door. You're checking its ID and legally declaring its category. You're casting variables explicitly as text, numeric, or date.
Let me pause you there, because a lot of platforms out there try to handle data typing automatically in the background.
They do try, yeah.
Why does datok force the user to strictly define whether a column is an integer or a string so early in the visual pipeline?
Well, it's really because of how the underlying storage engine operates. Datok relies heavily on SQLite for its local database operations.
Okay.
And SQLite has this very unique, highly flexible typing system known as type affinity.
Right.
So if you don't explicitly lock down the storage class, telling SQLite that this specific column must be evaluated as an integer, a real number, or text-t, it might try to dynamically interpret the data based on the values it sees.
And dynamic interpretation is just a recipe for silent failures. I mean, I have seen this happen in other tools.
Oh, it's the worst.
You leave a column of sales figures formatted as text. Now, to a human, the number 100 looks like a number, regardless of whether it's stored as a string or an integer.
Right.
But when you try to run a mathematical sort operation later, a text-based sort will organize values alphabetically rather than numerically.
Which means 10 and 100 will sort before 2, simply because the character 1 comes before 2.
Exactly, and if you try to run a sum aggregation on a text column, the operation might just return a 0. Or worse, it silently drops records without throwing an error flag.
Yeah, silent errors are the absolute bane of a data architect's existence. Typecasting at the select column stage ensures that the SQLite engine knows exactly how to compute the math later on.
That leads directly into the sort columns tool.
Yes, it does.
Once the bouncer has checked the IDs and labeled everyone, we order them. The tool handles ascending or descending sorts based on multiple levels of keys.
Right, so you can sort by region ascending, and then within each region, sort by profit descending.
We don't need to dwell too much on what sorting is, we all know that. But the documentation places it right alongside the select tool for a reason. Sorting early optimizes the macro structure before we start getting into the granular microscopic problems.
Exactly, so the macro structure is sound at this point. The columns are strictly defined, properly typed, and sequentially ordered. But the pipeline is still full of dirty rows. Zoom in on the actual data living inside those columns, and you will find the reality of human data entry.
A total disaster zone of typos, null values, and just irrelevant records.
Always, every single time. This is where the workflow transitions from structural architecture to micropolish.
Yeah.
And the primary mechanism for that is the filter rows tool.
Right. The filter tool uses custom SQL-like comparison logic. You type in a rule like sales greater than 100, and it evaluates every row against that rule.
Yep.
But here's the mechanism that really caught my eye. It doesn't just delete the data that fails the condition.
No, it doesn't.
The visual node graph, which the documentation notes is powered by a rendering engine called Cytoscape, physically splits the output streams on the canvas into a true line and a false line.
The implementation of Cytoscape here is really worth noting.
Yeah.
Yeah, Cytoscape was originally built for biological research to map complex protein interaction networks.
Wow, really?
Yeah. By repurposing that graph theory engine, datok visually renders the flow of data as physical edges and nodes in the browser's document object model.
That is so cool. So when that filter rule executes, we get a literal visual branching of the tracks.
Exactly.
The records that meet the condition go straight ahead down the true track to continue the analysis. But the false records get shunted onto a parallel siding.
And you can actually attach a data viewer to that false track and inspect what got left behind.
Which is huge. Consider the forensic value of that visibility. In legacy data preparation, when you apply a filter, the failed records just disappear into the ether.
Poof, gone.
Right, so if you made a typo in your SQL logic, say you typed greater than 1,000 instead of 100, you just lost 90% of your valid data.
And you might not even realize it until the final dashboard looks horribly, horribly wrong.
Exactly. By keeping the false stream physically alive on the canvas, datok enables real-time auditing of your own assumptions.
It prevents you from flying blind. So the irrelevant records are sidelined and the true records are moving forward. But earlier you mentioned the reality of human data entry, the typos, the invisible errors.
Oh yes, the messy stuff.
How does the system scrub those away without us having to write complex regular expressions for every single column?
Right, because nobody wants to write rejects if they don't have to.
Nobody.
Well, that is the specific domain of the data cleansing tool. It acts as the sweeping multi-tool for data hygiene. It targets those microscopic flaws.
Well,
It can systematically replace nulls, swapping in a 0 for numeric fields, or an empty blank for text fields.
nice.
It standardizes casing, forcing text strings into all uppercase, lowercase, or title case. And crucially, it trims out white spaces, leading, trailing, or duplicate spaces hidden right in the middle of a string.
I completely understand why title case looks better on a final PDF report.
Sure.
Changing a messy entry like a lowercase John Doe into a cleanly capitalized John Doe is just aesthetically pleasing. But we're building data pipelines here, not formatting a newsletter.
Fair point.
Does stripping a trailing space actually matter to the database engine?
It is arguably the most critical step for relational data modeling. The database engine does not care about aesthetics. It cares about absolute cryptographic matching when performing distributed joins.
Okay, walk me through that.
Let's say you have a customer table, and you want to merge it with a sales table using the city name as the key.
The classic join operation.
Exactly. In Table A, the city is registered as New York. In Table B, a human entered the data and accidentally hit the space bar before typing, so it's registered as Space New York.
Ah, I see where this is going.
To a human eye glancing at a spreadsheet, those two values look functionally identical. But when Squy attempts to hash those strings to execute a join, the hashes will be completely different.
Because of that one invisible space.
Yes, the mathematical signatures do not match.
So the join fails.
The join fails silently.
There's that word again.
Silently.
The worst kind of failure. The engine simply assumes they are two entirely different cities. Those sales records will completely vanish from your joined data set, and your final revenue numbers will be artificially low.
The data cleansing tool acts as an automated safeguard against those invisible points of failure. It normalizes the strings so the math actually works.
It's like finding a microscopic crack in the foundation before you even attempt to build the house.
That's a great way to put it. Okay, so at this stage, our data is structurally sound, we have filtered out the noise without losing our audit trail, and we have scrubbed every single cell clean of rogue spaces and weird capitalization.
We have a pristine data set.
Structurally and microscopically, yes. But we haven't addressed the final and often most hazardous issue in enterprise data: perfect clones.
Oh, duplicates.
Right. You can have a perfectly clean, perfectly typed, mathematically flawless row of data that exists 3 times in the exact same table.
Dealing with duplicates is where this documentation takes a really fascinating turn. It kind of elevates datok from a simple cleaning utility into something resembling an enterprise-grade auditing engine.
Yeah, let's break down the Dedupe tool.
So, similar to the filter tool we discussed, Dedupe splits the data physically. It routes unique rows out of a U port and isolates the duplicate rows out of a D port.
Okay.
But the real depth here lies in the cryptographic reference keys.
I found this absolutely wild when I was reading the docs. It is like placing matching, glowing radioactive trackers on identical twins so you never lose track of who is who in a crowded room.
That's exactly what it is. It's a highly advanced, heavily engineered feature for a local browser application.
Yeah.
When you execute the Dedupe tool, it doesn't just separate the clones. You can configure it to append a trace identifier column to both the unique output and the duplicate output, mathematically linking them together.
But I need to push back heavily on the specific options provided here.
Okay, what's your concern?
The documentation notes that you can generate these keys using simple sequential numbers. That makes total sense to me, tag 1, tag 2, tag 3.
Sure.
But it also offers UIDv5 using the SHA-1 namespace, hashlib standard SHA-256 hex hashes, and secure HMAC using HMAC SHA-256 with a secret key.
Yes, it does.
Why on earth would a normal data analyst need a military-grade HMAC cryptographic signature just to track a duplicate spreadsheet row? Feels like overkill.
If you view data preparation as just making charts for a marketing meeting, it absolutely sounds like massive overkill.
Right.
But you have to view this through the lens of corporate liability and strict regulatory compliance. Think about highly regulated environments.
Like banking.
Exactly.
Yeah.
Financial institutions auditing millions of ledger transactions or healthcare providers managing patient diagnostic records.
High-stakes environments where deleting data is a legal minefield.
Exactly. When you purge a $2 million financial transaction or medical file from the primary database because your system flagged it as a duplicate, you carry immense liability for that deletion.
Oh, I see.
If a federal auditor comes knocking 6 months later and asks why that specific ledger entry was removed, you cannot point to a simple sequential number and say, well, it was row number 42, so the system dropped it.
Yeah, that proves nothing.
Right. You need mathematical proof of the exact state of that row at the exact moment of deletion.
Okay, that actually clarifies the need for deterministic hashing, because UIDv5 and hashlib SHA-256 are deterministic.
Yes, they are.
They take the entire contents of that row, every single letter, number, and space, and run it through a one-way mathematical algorithm to produce a fixed string of gibberish.
Yep.
If the input data is perfectly identical, the resulting hash will always be perfectly identical.
Yes. By tagging both the retained unique record and the discarded duplicate record with the exact same deterministic cryptographic hash, you create an unbreakable, mathematically provable link between the survivor and the clone.
And that explains the HMAC SHA-256 option perfectly. HMAC requires a secret key.
It does.
That means a rogue analyst can't just maliciously delete a record, manually type out a fake hash, and cover their tracks. Without the secret key, they cannot spoof the signature.
It provides seamless, tamper-proof downstream traceability. An auditor can pull up the discarded file and the false track, look at the HMAC signature, and instantly find the exact surviving record in the main database to verify they were true clones.
It fundamentally elevates data preparation from a housekeeping chore to an act of forensic accounting.
Absolutely. It ensures that every single transformation your data undergoes is intentional, documented, and beyond reproach.
Which brings us back to the core philosophy of this entire system. You are acting as an architect.
You really are.
So what does this actually mean for you, the listener, when you start working with these tools? Let's distill the journey we just took.
Well, the overarching narrative is total control and absolute visibility.
Right.
By relying entirely on your local disk and your system's RAM, you maintain absolute privacy.
Right.
You're completely avoiding the security risks of uploading sensitive corporate files to a remote black box in the cloud.
But because you are local, you have to respect the physical limits of your machine. You protect your browser's heap memory by downsampling, testing your logic on small batches before pushing the heavy lifting to the SQLite database.
And from there, you sequentially, systematically dismantle the chaos.
Yeah.
You use select columns to strictly define the macro structure and lock down the data types so the database engine doesn't fail silently. You use filter rows to switch your data streams, preserving your false records on parallel tracks for constant auditing.
You apply data cleansing to scrub away the invisible formatting errors that secretly break your SQL joins. And finally, you deploy Dedupe to isolate redundant records, tagging them with immutable cryptographic hashes so you never, ever lose your audit trail.
You are turning raw chaos into pristine, auditable insights without ever leaving your machine.
It is a profoundly empowering way to interact with data. It removes the anxiety of not knowing what is actually happening inside your pipeline.
It gives you that working X-ray machine we were looking for at the beginning.
It really does. But as we wrap up this deep dive into Datok's Prep Essentials, there is one final detail from that documentation that I just cannot stop thinking about.
Oh, what's that?
Well, we've seen how the system uses advanced cryptographic hashes to perfectly tag duplicate mistakes, linking the error forever to the original record with absolute mathematical certainty.
Right.
It creates perfect accountability for the data itself. But think about the human element behind the keyboard.
Okay.
If every single data entry error, every careless typo, or every duplicated invoice in a company's entire history was permanently tagged with an immutable, traceable, cryptographic signature,
Wow.
how would that fundamentally change the accountability and the daily behavior of the people manually entering that data in the first place?
That is a terrifying but fascinating thought.
Something for you to ponder next time your finger hovers over the copy-paste shortcut. Thanks for diving deep with us today.